We'll teach you a little bit about how it works and what it does. So we take 110 volts that comes in from the wall over there, and we run it through a bank of transformers right down here at the bottom. Those transformers take that 110 volts and steps it up to 10,000 volts. Those 10,000 volts moves into our primary coil, which is the copper wire that's wrapped around the base. All that's going to do is it's going to start to take in all that potential until it hits a point where we can't contain it. Once we get there, we now have to move that somewhere else. So we move it into the secondary coil, which is the red part right there. All that is just a tube, and in our case, we have 1,500 turns of copper wire around the outside. What that translates to is it's going to take that 10,000 volts, step it up one more time to 500,000 volts. So we now have 500,000 volts moving around between our primary and secondary coil. The charge begins to build up here till it hits a point where it wants to break free. When we get there, we guide it to discharge and break free off of this round part here at the top. We call that a toroid or a capacitor. What that's going to do is it's going to take in all 500,000 volts, discharge it all at once, and what we get are these really fine electrical arcs that we can see. The visual display that we get is absolutely shocking. All right, a few people got it. So, 500,000 volts and some lame jokes, pretty awesome stuff. But to me, the really cool thing that's happening is there is a 3 kilohertz or a 3,000 cycles per second propagation of energy that is coming from that secondary coil. That is the wireless energy Nikola Tesla was talking about. That's what he was testing for. So, cool fact. Everybody within about 20 to 30 feet of the Tesla coil here would get a really interesting effect where your phones would start to get a nice charge, the screens would get just a little bit brighter, and then they would die. Our electronics are not meant to handle 3 kilohertz at this amplitude. So, before we start getting nervous about our very expensive electronic devices, we do have something that is keeping them and us safe. I'm sure you guys have noticed the cage around the outside here. This is not just for decoration. This is called a Faraday cage, and it's doing 2 things for us that I'm really happy for. If we take a notice, it's a nice symmetrical grid. It goes all the way around the Tesla coil. We've grounded out with a wire at the bottom there, and it's also made of iron. What all of that translates to is, as that propagation of energy comes forward, it hits the cage and grounds itself out. That means your electronics are perfectly safe. That's really nice. The other thing I'm actually a little bit happier for is 500,000 volts discharging out the top here is a really neat but kind of a scary thing. Now, the electricity does not like moving through the air, so it'll ground itself the first opportunity it finds. So we've given it this nice iron, already grounded cage, so it doesn't choose the water-filled meat bags that are standing closest to it. So, Igor and I are a little bit happier for fact number 2. Alright, so with that introduction out of the way, we're going to go ahead and start it up for you guys. If you want to grab your cell phones out and grab a video, now is definitely your chance. But 2 warnings. 1, it is very loud. And 2, do not come up and approach or grab the cage. I really hope the reason there is obvious. Alright.
Sam.
So, we're going to do a little countdown here for you guys, because countdowns just make things more awesome. Alright, are you ready, Igor? 3,